mining and mine reclamation. Okay, so we already learned about the rock cycle, but that's how we get our Earth's crust. It is composed of minerals and rocks, and the rocks are dependent on how they're formed. So if they're compacted together, they are sedimentary. If they are formed from cooling lava, they are igneous, and if they are formed because of heat and pressure over time of sedimentary and igneous rocks, then they are called metamorphic rocks. So this is another picture of the rock cycle. So mineral resources are fossil fuels. Examples of fossil fuels would be coal. Metallic minerals, examples of that would be aluminum and iron and copper. And some of your non-metallic minerals would be sand, gravel, and limestone. Now, since they form so long, it takes so long for them to form, they are considered and classified as non-renewable mineral resources. So ore is rock that contains a large enough concentration of a particular mineral, usually a metal, to make it profitable for mining and to actually process it. Now you have either high grade or low grade ore. It is less expensive to mine for high grade ore, and it's less harmful for the ecosystem to mine the high grade ore. So they're usually, for high-grade ore, it's a large amount of desired non-renewable mineral resource. Low-grade ore, however, is a smaller amount, and that's something that you're going to measure. You're going to get out only if you need to, because the high-grade ore is gone. Okay, so some non-renewable metal resources would be like your aluminum, and that's used for packaging and for cans, and usually for structures and our cars and aircrafts and buildings. Steel is used for buildings and in cars also, and usually it's got some kind of iron mixture in it, which is like an alloy, and then other elements are added also to give it either strength or bendability or whatever, but those are manganese, cobalt, molybdenum, and chromium. And then of course you have your copper, and that one's used for conducting electricity. And then you have platinum. It's used for electrical equipment, and it's usually a catalyst in industry and automobile and catalytic converters. And then gold is used for electrical equipment, jewelry, money, medical implants, and usually it's a catalyst to speed up certain chemical reactions. So very, very important. The life cycle of a metal resource. Here you can kind of see the each step in the process is going to use large amounts of energy and produce some waste and pollution. So if at all possible, it's important to go back to the recycling here, the smelting. So this is economically feasible and environmentally friendly to, once you discard it, to actually melt it back down again, because the surface mining here and separating the ore from the gangue, this whole process right here is very energy intensive, and it's not good for the environment. I feel like I skipped over the non-metal mineral resources. Let's not do that. My bad. So some widely used non-metallic minerals most are sand and gravel. And I know you feel like, wow, we see that everywhere. Why do we have to mine for it? Well, you do. Sand is usually silicon dioxide, and it's used for glass, bricks, and concrete. And gravel is used for roads and also making concrete. And then you have limestone, mostly made out of calcium carbonate, which is usually from the shells of certain sea critters. But limestone is used to make road rock and cement. And then phosphate salts, we know what phosphate is mined for. Yes, for fertilizers, and they put it in a lot of the detergents. So you want to look for phosphate-free detergent so it won't enter the water system. Okay, so basically on the left you have the three steps. You have the mining and the exploration, extraction, then the actual processing and transporting, purification, manufacturing of the ore, and then you have the actual use because of transportation to the individual user or in eventual use and discarding. So all three of those steps are going to lead to environmental problems. You could probably pick one that will be good for all three. They're all going to be health hazards. Yep, health hazards. I see health hazards on all three. So let's remember health hazards. There we go. Environmental effect, health hazards. All right. Okay, several ways to remove mineral deposits, and it usually has to do with the depth of the ore. Where is it located? Surface mining, this is if it's shallow. An open pit, basically you're going to have some kind of equipment. You're going to have something that's just going to pull the top off of the ground. And that stuff that you're pulling off the top of the ground is the overburden. And from the overburden, okay, so when the soil and rock that's on top of the useful mineral deposit is discarded, then it's usually the waste that's called spoils, and then they'll make spoil banks, which are basically large many ripples of the spoils. Strip mining, that's pretty much when you are, instead of just doing one big old pit, you're going to extract mineral deposits that are close to the Earth's surface in large horizontal beds. Contour is basically you're going to, if you're on a hilly or mountainous terrain, you're going to use power shovels and it's going to cut like terraces into the side of the hill. Mountaintop removal, that's common in Appalachia. Basically, they're just going to use explosive and remove the entire tops of the mountain to expose seams of coal that are then removed. Subsurface mining, that is when they're deep deposits, so you have to dig a deep vertical shaft and go down, and then you blast open tunnels and chambers to reach the deposit, and then you have to have machinery to remove the ore and coal and transport it to the surface. That's actually pretty harmful for the coal miners and dangerous, and you can have chances of land subsidence occurring in subsurface mining. But anyways, type of surface mining used depends on the resource and the local topography. That's a open pit mine in Western Australia. This here you can see the contour strip mining, how basically they just cut a terrace into the side of the mountain. But this one is problematic because sometimes it's high wall here. It's very prone to erosion. This is mountaintop coal mining in West Virginia. Mining has harmful effects, scarring and disruption of land surface. For example, the spoil banks that I was just telling you about. Those are problematic because they are
Sophomores, thank you for your...
So anyway, the spoil banks are like waves of rubble. What they do is they end up taking all the overburden and they will just dump it into rivers and streams, and they lose valleys because of this. And especially in particular, this is problematic in Appalachia. They say that the Appalachia rivers and streams, approximately 900 kilometers or 1,200 miles worth of the rivers have been buried, and 470 of the largest mountains have disappeared, and you have these ginormous pits. Some of the pits are as large as Manhattan Island. So 470 of the largest mountains have disappeared, and that was as of like 2008. I'm sure that number has increased because they passed a law saying that they continue to use mountaintop removal. Problematic, major pollution of water and air. When they store pretty much the coal waste. They have sludge dams. These can overflow and collapse, and they can release toxic substances like the selenium and arsenic and mercury. Toxic wastewater, when the coal is processed, is even stored. Subsidence is when the land sinks. Effect on aquatic life, obviously, they're losing volume of water, but the water that they do have is also becoming polluted, and there's large amounts of solid waste. Here's a spoil bank. These pretty much have to go through primary ecological succession. Therefore, it's going to take a lot longer for this to become soil. Now, is it possible? Yes. Here's an example of an ecological restoration of a mining site. So basically, they call restoration of mining reclamation. You reclaim the land, and they usually have to help it out by spraying some unique material. It looks kind of like green toilet paper onto the onto the rock to get it started quicker. Mechanism for primary productivity to happen. Okay, removing metals has harmful environmental effects or extracted by mining. So you have the ore mineral. So when you first pull the overburden and then put the spoils back, you are left with the ore, which looks like your chocolate chip from the mining lab. And then remember, on that chocolate chip you had a little bit of cookie still left there. That cookie that was left behind is the gangue. Now if you want to remove that gangue chemically, you will have left over. As soon as that gangue is removed, and then now it's removed as waste, and now it's called tailings. And remember, that is toxic because they're using toxic chemicals to remove the gangue from the ore. And then to further, if it's a metal, to further purify it, they melt it, and they have different melting points, and so that way you can get more of a pure metal that way. By doing this, you have water pollution, you have a lot of liquid and solid hazardous waste, and they use cyanide salt to extract gold from its ore. That's the tailing that it produces. That's the cyanide they use to create tailings for gold. Here's a site of Summitville Mining. This was in Colorado. And This is a toxic site because a Canadian company actually owned it and then declared bankruptcy and abandoned it. So they didn't clean it up, and so now the acids and toxic metals have leaked into the nearby Alamusa River. And so EPA's cleanup is going to cost taxpayers about $120 million. Strategic metal resources, so in other words, these are the ones that are used in military, and the country that has the largest quantity of these is South Africa. Future supply. Okay, so supplies can be economically depleted. Remember, if 80% of it is depleted, it's considered economically depleted. So if that happens, then you need to recycle or reuse existing supplies, waste less, use less, find a substitute, or do without. Now, the three ways for which to increase the reserve, which would increase, it means it no longer will be economically depleted, would be to either, first of all, have new technology, better technology that allows you to reach the lower grade ores to make it more high grade ore. If it's you find more, or if it becomes more desirable to actually mine more when it becomes less common in the marketplace. This is depletion curves. Now, obviously, depletion time is going to be greatest if you mine, use, throw away, no new discoveries of technology, or no new discoveries of ore, and then rising prices. And obviously, it's going to take less time if we decide to reduce, reuse, recycle, and reduce consumption, increase reserves by improved mining technology, et cetera, et cetera. So market prices affect supply. So that's what I was trying to say. So subsidies and tax breaks to mining companies keep mineral prices artificially low. They have some of the lowest fees and royalties that they have to be paid are to miners. Subsidies basically means that they feel, and the mining companies feel, that since they are providing so many jobs and they do provide a lot of state revenue and taxes for the state, that they should have to pay fewer royalties to mine land. But basically, it keeps the prices of minerals artificially low. And if we were to have the correct price on these minerals, then perhaps we would start using human ingenuity to come up with replacement. Does this promote economic growth and national security? So there you go. So we aren't discovering and making new discoveries because we don't need to. At this point, we probably should be coming up with some more alternatives. Okay, what is the case study? U.S. General Mining Law of 1872 encouraged mineral exploration and mining of hard rock minerals on U.S. public lands. So basically, they're saying that if you would move out west, you could purchase land for $6 to $12 an acre as long as you agreed to spend at least $500 in making it better and invest $500 in developing that land, then you could buy it for that cheap. Unfortunately, a lot of countries were coming in, a lot of companies from other countries, and they were purchasing land for that price, and they're pretty much just going bankrupt before they would actually clean it up. So you had to pay, it was like $120 per year for the parcel of land to maintain it, even if the mine wasn't in operation. But like I said, the companies would just go bankrupt, and then that means that the taxpayers would have to be the ones that would clean it up. And what's frustrating about this is that the mining companies, they were only paying royalties. They're paying 2.3% of the royalties. So oil companies and natural gas, and they had to pay 13.2%. 14% of royalties have to be paid for grazing. So it's a little bit frustrating, and especially since this was near Crested Butte, and the land could be worth as much as $155 million. We can find substitutes. Materials revolution. This is basically where you have silicone and other materials like ceramics and plastic are being used to replace these metals. Nanotechnology, that's going to lead to development of materials that can serve as substitutes also. Examples. They have Gancrete, and that's that styrofoam that's sprayed with ceramic spray. And since ceramic is affordable and it's very, very strong, they say that this is twice as strong as the structural concrete, so it won't leak and crack. So that sounds pretty cool. They can use fiber optic glass cables. They transmit pulses of light, and now that's going to be replacing some of the copper and aluminum wires and in phone cables. They're thinking nanowires might end up replacing those optic glass cables. And then they have some high strength plastics and composite materials they're using, and they're trying to use this plastic. However, we know that there are some drawbacks to plastic, because why? What needs to go into plastics? They're made of petrochemicals, so basically you need oil and other fossil fuels to make them. But they have started looking at plastics made from plant materials. If you look around, sometimes you can find bowls and they'll say made out of corn. We actually have some, so if you want to, come see us and we'll show you some of these things. Unfortunately, substitution is not a cure-all. Platinum is an industrial catalyst, and chromium is an essential ingredient of stainless steel. But we can recycle and reuse. In recycling, it's much better to melt down the end product of metal and processing it than it is to actually begin from start to finish processing metals from ores. There's different types of recycling. Basically, your closed loop recycling is also called primary recycling. Basically, the materials that are being recycled, they are going to be melted down and then turned back into the same material. Like your aluminum cans will be melted down and then turned back into aluminum cans again. And then the other kind would be secondary recycling or open loop recycling, when after they're melted down, they are turned into something else that is open or secondary. Now, reusing is simply using it in the same form without melting it down again. Which is better? Yep, reusing. Solution: don't waste mineral resources, recycle. Reduce mining subsidies. We should reduce all subsidies. Increase subsidies for recycling, reuse, and finding substitutes. Increase perhaps the amount of money that you get for recycling, and slow population growth, because that's easy. Right. Anyway, mimic nature, resource exchange webs, eco-industrial parks, industrial forms of biomimicry. So in other words, if companies can use the waste product of one company in order to have the primary product for the next company, it would be good to go. Like the sludge for pharmaceutical plants can be used as fertilizer for local farmers, and the fish farm sludge can go to local farmers for fertilizer. Heat can be used for greenhouses, it can be used for area homes, etc. I think you get the idea. So the byproduct from one can be the new ending product for the other.